Myself, Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding the definition and terminology of input-output organization and memory organization. First, define system bus. A bus is a communication pathway that is connecting two or more devices, usually in the broadcast the signals. So the basic layout of the bus is like this. So to connect two devices and to establish communication path between two or more components of the computer, the system bus can be used. The system bus is categorized into address bus, data bus and control bus. So these three are clubbed together forms the system bus. Here by using this system bus, the central processing unit and memory subsystem is connected, as well as I/O devices can be connected with the CPU and memory system. The address bus is generally used to carry the address of the memory location. So it is a unidirectional bus. The data bus is carry what information or data that is fetched from or write into the memory. So the data bus is of bidirection, and the control bus carries the control signals like read, write, memory function complete. These signals can be traversed with the help of control bus. The control bus is a bidirectional. So the I/O devices can connect with the CPU and memory system with the help of the system bus. So the data bus carries the data, and the width is the key determinant of performance of the system. And here the width can be generally 8, 16, 32 and 64 bit. Next, the address bus is identify the source or destination of data. So it is used to refer the memory location. CPU needs to read an instruction from the given location in the memory. That location can be carried out or pointed with the help of the address bus. The bus width determines maximum memory capacity of the system. If there are k address lines, then 2 power k is the address space that is provided in the memory. For example, in the 8080, 16-bit address bus can be used. 2 power 16, 64k address space is available. The third bus is the control bus. The control and timing information is carried out with the help of this control bus. Memory read, memory write, I/O read, I/O write, acknowledgement transfer, and in case of DMA controller, bus request, bus grant, interrupt request and interrupt acknowledgement, clock, reset, all these signals can be traversed with the help of the control bus. What are the characteristics of the bus system? So here major parameters or the design issues for the bus configuration is bus type. So it is a dedicated bus or a multiplexed bus. Dedicated bus means separate data and address lines can be used. In case of multiplexed bus, the shared lines of address valid and data valid control lines can be used. And the second parameter is bus arbitration. So in case of multiple buses, which bus can be chosen for transmission of data or address can be decided with the help of bus arbitration. Arbitration may be centralized or distributed. Next parameter is timing. The coordination of events on bus sync is determined with the help of synchronous or asynchronous timings. Synchronous means here the two devices that involved in the communication can share the same timing signals. Otherwise, it can be considered as asynchronous communication. Bus width. The width of address bus has an impact on the system capacity. So, if there are k address lines, then 2 power k is the address space of the memory. Data width. Width of the data bus has an impact on the system performance. Wider bus means number of bits transmitted at one time. So, the data width can determine the word length of the system. So, how many bits per word can be defined with this data width. So, which in turn affects the system performance. These words can be transmitted at a time. So, the data width can has a major effect on the performance of the system. Next is data transfer rate. Either it is a bit transfer, byte transfer, or word or block transfer can be major parameter in the bus configuration. These are the characteristics or the parameters, the design issues that can be considered for the system bus. Next, define data bus. Data bus carries data from one component to another component. So, here on the memory, generally two operations are usually performed. One is read operation, another one is write operation. The data that is going to be read from the or fetched from the memory, or the data that is going to be write on the memory can be carried with the help of the data bus with the help of MDR register. It is unidirectional for input-output devices and bidirectional for the memory and CPU. What is control bus? Control bus carries control signals like memory read, memory write, input in case of I/O devices, input read, input write, and in case of DMA, bus grant, bus request, all these are various control signals. These control signals can be traversed with the help of the control bus. The control unit of the CPU uses control signals for controlling all components. The major function of the control unit is to control or to make coordination among various components of the computer. With the help of these control signals that can be traversed with the help of control bus, the control unit can controlling all the components of the system. It is unidirectional from CPU to all other components. Next, define address bus. Address bus carries memory addresses. So, what data has to be written into the memory, at which location the address is contained in the memory address register. This address is carried with the help of the address bus. A memory address is a numerical value used for identifying a memory location. So, with this address only, the storage location can be uniquely recognized. Computer performs its entire task through the memory addresses. Control unit of the central processing unit send memory addresses to all components. So, address bus is also the unidirectional from CPU to all other components. Define computer register. So, here we are having various storage components in the computer like registers, cache, as well as primary memory, secondary memory. Registers is the one of the quick accessing mechanism. Why? Because they are easily available on the CPU itself. And registers is a very small storage capacity. Registers are a type of computer memory used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU. A processor register may hold an instruction, a storage address, or any data. The computer need processor registers for manipulating data, a register for holding a memory address. So these are the readily available on the processor. So the data can be easily accessed by the CPU for the processing. In the computer, there are some set of predefined registers. One is the data register. So the data register is of 16-bit storage capacity. The data register can hold the data that is that is write and read or fetch from the memory. Next is accumulator, which is represented with AC and it is of 16-bit. The accumulator register is generally used with the arithmetic logical unit for processing. To perform these arithmetic or computational processing, the accumulator can hold the one of the operand of the computational activity. Next one is PC, program counter, which is of 12-bit storage capacity. The PC can store the address of the next instruction that is being executed by the CPU. Next, AR, address register. Address register holds the address of the memory location where the write operation can be take place or from which the content can be fetched is pointed with the help of the address register. Next is IR, instruction register. The instruction register is of 16-bit size and which is used to store the address of the current instruction that is being executed by the CPU. Next, TR register, temporary register, which is of 16-bit size. So it is used to store intermediate values that are generated during the processing. Next, INPR and OUTR are the two registers which are 8-bit of size and can be used for input and output storage buffer purposes. These two in INPR and OUTR register can be used. All these are the generally the registers that are available with the computer. Apart from this, a set of general purpose registers can be available. Those can be ranged from R0 to Rn-1. The number can be depending upon the processor. What is memory hierarchy? So, in the memory, there are variety of storage elements or components are available. The registers, cache memory, primary memory, and secondary memory. How these hierarchy are order of the access time based on the how it is far, the location can be far from the CPU. Depending upon various parameters, the memory hierarchy can be defined. The memory hierarchy is to obtain the highest possible access speed while minimizing the total cost of the memory system. In this way, the storage elements can be arranged. The access time increases with the distance from CPU and the cost per bit is decreases with the distance from CPU. So here the first storage accessing medium is the CPU registers which are readily available on the processor. So these are the quick accessing mechanism. Next is L1, L2, L3 cache systems. The next order is the main memory. Next is the secondary memory. But the storage capacity can be increased from distance from CPU. And here the accessing speed the registers can have high. Next ranking is the cache. Next main memory and the secondary memory. What is the cache memory? A cache is a small high-speed memory placed between the CPU and the main memory. So here, during execution of a program, the CPU can reference some instructions more frequently. In case of looping structures and control structures, the instructions can be referred repeatedly. Those instructions generally stored in the cache. So a copy of some part of the main memory can be transferred to the cache. So during execution, the CPU first searches for the instruction in the cache memory. If at all the instruction that is searched for is available in the cache memory, then that is a hit operation. If at all the required or demand instruction is not available in the cache, it is a miss operation. In that case, the CPU can search for the demanded instruction in the memory. So a cache is a small, very fast temporary storage memory. It is designed to speed up the transfer of data and instructions. It is located inside or close to the CPU chip. It is faster than the RAM. The data instructions that are most recently or frequently used by the CPU are stored in the cache. So cache is placed between CPU and the main memory. Cache is the fastest component in the memory hierarchy and approaches the speed of CPU components. Access time to cache memory is less compared to the main memory. It contains a copy of portions of the main memory. Cache memory bridges the speed mismatch between the processor and the main memory. So the synchronization of the speed can be done with the cache memory in between the processor and the main memory. So here this is the main memory and this is the central processing unit. In between the cache memory can be connected. It is a small high-speed memory. So some part of the main memory, most frequently used instructions can be stored in the cache memory. So from the main memory to cache memory, a block transfer, the unit of transfer is the block. From cache to CPU, word transfer, the unit of transfer is the word transfer. What is the need for the cache? The data and instructions are retrieved from RAM when CPU uses them for the first time. A copy of the data or instruction is stored in the cache. The next time CPU needs the data or instruction, first we can look into the cache. If the required data is found, then it is retrieved from cache memory instead of the main memory, so that the speed of execution can be increased with the CPU. Next term is what is associative memory. So here, whenever the content of the main memory can be accessed, it is possible with the address only. By specifying the address, the content from the main memory can be retrieved. So the time required to find an item stored in the main memory can be reduced considerably if stored data can be identified for access by the component of data itself rather than by address. So here, to retrieve or to fetch any information from the memory, the storage location or the memory address is important in order to identify what data is read or written. Instead of using these addresses, directly the content can be used for searching in the memory. Then the performance of the system can be increased. So a memory unit accessed by content is called as an associative memory or content addressable memory, CAM. So these memories can be accessed with the help of content rather than by the memory address. CAM is accessed simultaneously and in parallel on the basis of data content rather than by specifying address or location. How to perform read and write operations on this associative memory? When the word is to be read from an associative memory, the content of the word or part of the word is specified. The words that matches with the specified content are located by the memory and are marked for reading. So, the search word, if it are found, those content locations can be marked for reading. When a write operation is to be performed on the associative memory, no address or memory location is given to the word. The memory itself is capable of finding an empty unused location to store the word. In this way, the read and write operation can be performed on the content addressable memory or associative memory. Then what is the difference between RAM and this CAM? So here RAM stands for random access memory, CAM stands for content addressable memory. So user supplies an address and RAM returns the word present at that location. So to refer the memory address is a must in case of the RAM. But user supplies a word and CAM returns the link where word is present. So with the help of the content, the fetching operation can be done in case of the CAM. RAM is cheaper than associative memory. CAM is costlier. RAM is used to run programs and store their data during execution, but CAM is primarily used for database management applications. RAM is suitable for from parallel RAM algorithm. CAM is suitable for parallel access. So these are the major differences between RAM and CAM. So how these content can be addressed with the help of two registers, argument register A and key register K. Argument register can hold the search word. Key register is used for the masking. So here the associative memory cells can be stored here. It can receive input and read-write signals, and if at all the corresponding cells are identified with that matches with the argument register, the match register value can be marked here so that the search operation is successful. In this way, the content addressable memory can be worked. So here within the associative memory, the cells or the words are matched with two indexes, the row and column sizes, and for each bit, the search word argument register and the mask value has to be compared with the word value. If they are equal with the word, then the corresponding match bit can be represented as high. So for example, if at all the argument register contains the value 1014100 and K is 111000000, and if at all where K is 1, those locations can be used to compare. Why? Because K provides the mask for the searching operation. If at all the stored word 1 is this, these values can be compared with the argument register, so there is no match. In case of word 2, these values has to be compared with the argument register. Both are equal, then there is a match can be exist. So in this way, the CAM can be operated. The next term is define auxiliary memory. The storage capacity of the main memory is also very limited. So often it is necessary to store hundreds of millions of bytes of data for the CPU to process. Therefore, additional memory is required for the computer systems. This memory is called auxiliary memory or secondary storage memory. So here, in this type of memory, the cost per bit of the storage is low. However, the operating speed is slower than that of the primary memory. So, to extend the storage capacity of the computer system, the auxiliary memory or the secondary storage can be used. So, what are various secondary storage devices? magnetic disks, floppy disks, hard disk and drives are the various categories of the auxiliary storage devices. These are the various auxiliary storage devices. For the magnetic storage, this is the hard disk. So here this is the floppy disk. This is magnetic tape. And in the optical storage, CD, DVD, Blu-ray disc. In case of flash storage, pen drives, scan disks are the examples of various auxiliary memory devices or secondary storage devices. Next, what is virtual memory? So here the computer, the memory that is available with the computer is limited. The virtual memory creates the user with an illusion that he is working with a large voluminous memory. So early days memory was expensive, hence small. Programmers were using secondary storage for overloading. But programmers were responsible for breaking programs into the overlays, decide where to keep the secondary memory, arranging for transfer of overlays between main memory and secondary memory. So, these programs are generally stored in the secondary storage devices. And whenever the CPU want to execute, these has to be transferred to the main memory for the processing. So, in this way, the programs can be traversed between the main memory and to the secondary storage. But in 1961, Manchester University proposed a method for performing the overlay process automatically, which has given rise to the concept of the virtual memory today. So, with the concept of the virtual memory, the programmers can have an illusion that that he is working with very large volume memory and CPU can executing at once stretch the program. So here addresses used by the processor for instruction or data are called the virtual or logical addresses. Virtual addresses are translated to physical addresses by a combination of hardware and software components. So two spaces are available. One is address space, another one is memory space. Addresses used by the programmer is called virtual addresses, and the set of such addresses is called the address space. Addresses used by main memory is called the physical addresses, and set of such locations are called the memory spaces. Address space is allowed to be larger than the memory space in computers with virtual memory. So, how the mapping can be done between these virtual address space and the memory space? So, with the help of page number and line number, the page number can be used as index to access in the virtual memory table. The virtual memory table can use it to represent the content that is stored, the blocks that are loaded or invoked in the main memory, and that presence can be represented with the help of presence bit. So, this is represented block 3 and it is loaded in the main memory. So, the presence bit of that block can be indicated as 1. So, the page number can be used as index to search in the virtual memory table. So, 101. So, here 101 is this location. So, here the block 01 and it is loaded in the memory. The presence bit can be copied to the buffer register. With the help of this 01, the main memory address register can be accessed and the line number can be used to represent the corresponding location of the memory. From that, the value stored at that location can be used to retrieve into the MBR register. In this way, the memory mapping logic can be established with the help of virtual memory table. What are cache mapping techniques? Cache mapping is a technique by which the content of the main memory are brought into the cache memory. Here, between main memory to cache, a block of transfer can be used. So the unit of transfer is block. But between cache and CPU, the unit of transfer is word. So there is a mapping logic required between the block and word transfer. So in cache, data is transferred as a block from primary memory to cache memory. So to map this process is called cache mapping. There are three types of mapping techniques are available: direct mapping, associative mapping, set associative mapping. So in case of direct mapping, to map the block of main memory to the particular line of cache, the line number has to be identified with the help of main memory block address modulus of number of lines in the cache. With this, the line of the cache can be identified. So here, the physical address can have the tag field line number. Both can be used to identify the block number. Next, the line offset can be used as the physical address. So here, these are the blocks that are available in the main memory. So block J location can be identified. J mod N and N lines are there in the cache memory. So that the identified location, there the block can be mapped to this cache main memory to cache memory. The mapping can be achieved with the help of direct mapping technique. The second method is associative mapping technique. In this, a block of main memory can map to any line of cache that freely available at that moment. So here, this makes fully associative mapping more flexible than the direct mapping. So here, if there are free lines are available in the cache, directly the mapping has to be takes place. So the physical address is block number and the tag block number are the line offset. The third method is set associative mapping. So the set associative mapping is the combination of direct mapping and the associative mapping. So here in the set associative mapping combines the direct mapping with fully associative mapping by arrangement of lines of a cache into sets. The sets are persistent using a direct mapping scheme. However, lines with each set are treated as a small fully associated cache where any block can save in the set can be stored any line inside the set. Set associative mapping allows that each word that present in the cache can have two or more words in the main memory with the same index address. Thereby the set can be defined. So here these are the set with the tags and these are the cache line numbers and these are the blocks that are present in the main memory. So here the physical address field can has to use the tag, index as well as the offset. So the word offset is used to identify which word of the block we want to access. The set number is used to identify which block in the main memory is to mapped which is set in the cache. Tag is used to uniquely identify each block in a set. So here calculation of the number of tags bits is simply subtracting word offset and the set number bits from the main memory bits. So what is the comparison between these three mapping techniques? So the direct mapping is simple one. Map each block of main memory into only one possible cache line. But in case of associative memory, permits each memory block loaded into any line of the cache. The cache control logic interprets a memory address simply as a tag and word field. So, which line is freely available in the cache, that line the block can be mapped. To determine whether a block is in the cache control logic must simultaneously examine every line tag for a match. But in case of set associative mapping, the combination of direct mapping and associative mapping can be used. A compromise that exhibits the strength of both direct and associative approaches while reducing their disadvantage is the third method, set associative mapping. So these three are the CACHE mapping techniques. What is input-output interface? So input-output interface, in short it is referred as IOP, is used as a method which helps in transferring of information between internal storage devices, that is memory, and the external peripheral devices. So here each and input-output device is used to provide the computer the communication. So the interaction with the outside world for the computer is provided with the help of these peripheral devices. So monitor, keyboard, hard disk, all these are various devices. They can interact with internal component of the system with the help of interfaces. That is called IOP. Why this IOP is needed? So the nature of the peripheral devices is the electromagnetic devices, but the computer component are the electronic devices. So the mode of operations of both peripheral devices has to be matched. There is also synchronization mechanism can be required to match the data transfer rates between the peripheral devices and the CPU. And the data codes and formats are differ from peripheral devices to the memory. To make the synchronization, IOP is required. The operating mode of peripheral devices are different and each may be controlled not to disturb the operations of the peripheral devices connected to the CPU. To synchronize and to mitigate the mismatches, the IOP can be required. What is strobe? The strobe is a control method of asynchronous data transfer, employs a single control line to time each transfer. So, in the input-output devices, the communication can be controlled with the help of two control lines. One is the strobe control line, another one is the handshaking. This control line is called the strobe and it may be achieved either by source or destination. Two types of strobes are available. Source initiated strobe. Second one is destination initiated strobe. A pulse supplied to indicate the time at which data is being transmitted is generally referred as the strobe. What is source initiated strobe? This is the source unit and this is the destination unit. The data bus, and along with the data bus, the strobe control line has to be traversed from source unit to the destination unit. So during this strobe signal initiation only, the valid data can be transferred between the source unit and the destination unit. This is the strobe signal. During the strobe pulse only, the data transfer can be transmitted between source unit and the destination unit. That is referred as source initiated strobe. The source unit initiates the strobe signal. The second method is destination initiated strobe. In this case, the destination unit generates the strobe signal to the source unit. So during the strobe pulse only, the valid data can be transmitted between the source and the destination. Define handshaking. A control signal is transmitted along with the data. Other signal is sent by the receiver. So to acknowledge the data transfer, handshaking mechanism can be used. So it has to provide the guarantee that valid data is transmitted and the receiver can send the acknowledgement signal. The unit receiving data item respond with other signal to acknowledge recipient of the data. In this way, it can guarantee the data recipient. So here the source unit and the target unit, data bus, data valid. After receiving the data accepted, an acknowledgement can be sent from destination unit to the source unit. So here during data valid, after traversing the valid data, as soon as received, the destination unit has to send the data accept signal. So thereby it can guarantee the recipient of the data. And destination initiated handshaking. In this also data bus, data valid, and here the ready for data, it has to receive the data, can be sent by the destination unit to the source unit. In this way, the handshaking mechanism can send an acknowledgement to the source so that the data can be received or it is ready for the data. What is bus arbitration? The bus arbitration procedure comes into picture whenever there is more than one processor requesting the service of the bus. So here, which process has to select for communication or can grant the bus can be determined with the bus arbitration mechanisms. Define distributed arbitration. In distributed arbitration, all devices participate in the selection of the next bus master. So, for the communication, which device has to be elected as the bus master. In this scheme, each device on the bus is assigned a 4-bit identification number in order to recognize the device and can be elected as the bus master for the communication. What are interrupts? So interrupts can be interrupt is a signal that can be raised by the input-output devices when they require the service. When IO devices is ready, it sends the interrupt signal to the processor via dedicated control line. Using interrupt, ideally eliminating waiting period of the process, so that the processor can understand and can grant the communication mechanism and data transfer to them by using the IO devices. These interrupts can be identified with the EI interrupt enable and interrupt disable signal mnemonics. So define parallel port. So it transfers data simultaneously from the devices. It uses multiple pin connectors. Parallel port is used to send and receive data using a group of bits simultaneously. So parallelly, the data can be transferred by using these parallel port pins. What is serial port? It transmits and receives data 1 bit at a time. For long distances, it is convenient and cost effective. So, all these are the terms and definitions pertaining to the input-output as well as memory organization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.